Welcome back to Geometry, Chapter 10, Section 1 in this book. But what we're going to be talking about is tangents to circles. So before we do that, we need to talk about parts of a circle. You're like, I've known about circles since I was 2. Well, you're going to learn a little more today. All right. So a circle, this is shaped as a circle. The very center is called the center, and it's equidistant to every point along the circle. That's this fancy math definition. A line from the center to the side is called the radius. It's red, because when I used to teach public school, I had a red little piece of yarn on my desk that I would use to teach radius and something you're going to learn in a minute, radians. Not this tape, but a couple of tapes. All right, if you go all the way across the circle straight through the center, it's the diameter. So the diameter, gotta say that carefully, is twice the radius. All right. If you have a line that cuts across the circle and its endpoints are on the edge, it's called a chord. And I always remember that because it kind of looks like the center of a guitar with the strings going across. So maybe that'll help you. If the line keeps going like a real guitar, so the chord, you're inside the guitar looking out and you just see that little bit. But if you're outside the guitar and you see the whole string, it's called the secant. Secant. If you have a line that is going next to a circle and it's only touching it in one place, it's called the tangent. If a point is outside of a circle, like that green one right there, it is called an exterior point. If the point is inside the circle, like that green one, it's called an interior point. Now, notice we've been talking about tangent with our trig. So what does this have to do? The relationship of circles and the triangles that you can draw inside of them is where trig comes from. There's ratios that are generated by putting triangles inside of circles. I know it sounds crazy, but I'll draw it over here and sort of let you see. See, if I take this circle and I start at the center and I go up until I hit the edge of the circle and I drop it down to the radius, I have a right triangle. And there are relationships between those sides and the angles inside the circle, and that's where trig comes from. So that whole tangent thing we've been doing comes from this relationship of this line to a circle. Sine and cosine is the same thing. This is like if you took and you drew the top half of a circle, then the bottom half of the circle, or say you start right there and drew a quarter of a circle, the bottom half, the top quarter again. These are called sine waves and cosine waves, and that's where sine and cosine comes from. It comes from this relationship between drawing circles and triangles and the angles. And if you're like a math major, you can learn a whole lot more about that. There's more to learn than what I'm going to teach you. We just don't have time. All right, so circles are congruent if they have the same radius, the same size. Now, we can have different ways that circles can interact with each other. They can have 2 points of intersection like the blue circles, 1 point of intersection like the red circle. See, the outside one and the inside one meet just right there. That little red one and big one meet right there, 1 point. Or they can have no points. They can just be spread out, or they could be like, I always think of these like cake pans, like a wedding cake, and they don't touch anywhere. Now, these circles only had 1 point of intersection. I drew tangent lines on. Remember, tangent lines are to only touch the circle in one place. This line is said to be internally tangent, and this one is externally tangent. And I'm going to show you, we don't usually look at it like this, we look at it like this, okay? So here we have 2 circles, and they are touched, they are sharing tangents. This line only touches this circle at 1 point, and this circle at 1 point. This line only touches this circle at 1 point, and that circle at 1 point. The lines go inside the circles, so it's internally tangent. Here, the lines are only touching the circles in one place, but it goes outside the circles. It's externally tangent line. So that's how you see it more than that. Okay, now another thing about tangent is when you have a tangent drawn to a circle, and you draw a line from the center to that same point, a radius, radii is plural, not radiuses, it makes a right angle. And so that's a tangent theorem. So if you want to know if this line is tangent, it will make a right angle. That's the vice versa. All right, so here's an application to it. Remember how we did like rect and length, will it taco, we did will it triangle? Well, we're going to do will it tan, or is it a tangent, and not brown skin. Never mind, I was about to go on a tangent about brown skin. So my boys were saying I was looking leathery. Anyway, that I needed to not be in the sun so much. I needed to apply sunscreen to my life. All right, so is it tangent? If it is a tangent, then it will make a right angle. So how we can test it is the Pythagorean Theorem. A squared plus b squared is c squared. So we have three sides here. It's hard to tell, especially with my bad drawing, if it is a right angle or not. So we first find the longest one, 61, and we substitute it in for c squared. Remember, a and b, it doesn't matter, but c has to be the long one, the hypotenuse. So then we take the other two legs and put them in, and we see, is 11 squared plus 60 squared 61 squared? And it is. So no matter how bad my drawing is, yes, it is a tangent. All right, here is another application of this. And math books love this problem, just like they like to know how tall the tree is, how many watermelons you're going to buy, and if you're going to join the video rental club or not, even though they don't exist anymore. They like the grain silo. You are standing by a grain silo. Where I live, we don't have a lot of those, but out west, this problem is for you. All right, so you're standing by a grain silo, and you're standing, there's a line tangent from you to the grain silo, and you know that it's 16 feet this way, and it's 8 feet this way from you to the grain silo. What is the radius of the grain silo? We can figure it out using Pythagorean Theorem, and knowing that this line is tangent, we know it's a right angle, so we just have to think about what's the biggest side of this triangle, and it's this side, 8 plus the radius. So I put it over here to square it, and then the legs are radius and 16. I had to square this by using FOIL. I had to use the distributive property. 8 times 8 is 64. 8 times r and 8 times r, or both 8r, add them together, you get 16r, and r times r is r squared. And 16 squared is 256. Now I gather up my terms, and so I'm going to put my r squared to the other side. Well, r squared minus r squared marks out. That's convenient. I won't have to use the quadratic equation. Now I get my 64 to the other side, because y's are not alone. It's being multiplied by 16 and has a plus 64, so first we do the opposite, minus 64. And then that's 192 equals 16r, and then we divide both sides by 16, and the radius equals 12. Whew, it was so important that we found out what the radius of our grain silo was. I think there would have been an easier way. All right, so here's another little theorem. If you have a point that is tangent to both sides of a circle, then these two lines going from the point to the tangent points are equal to each other. See my little red lines, meaning they're equal? So we can apply this. Here's a point, go into a circle, these lines are tangent. On this side, it's x squared plus 2. On this side, it's 11. So we just set them equal. X squared plus 2 equals 11. We say y is x not alone, it's got a plus 2, subtract 2 from both sides. Take the square root of both sides to get rid of the squared. And x, I said, is 3, but the book said plus or minus 3. Remember I told you they're totally arbitrary of when they want you to just say 3 and when they want you to say plus or minus 3. But don't worry about it. Just, whatever they're doing for that section, do that. All right, I think you should like this. I like it. This is fancy math. We're talking about tangents. Fancy. All right, math is great. See you next time.